Hi guys, I have a question. I don't understand a little bit.
What is it?
This is the question one, and the other one is a little bit confused about it. So let's do together. We will find the solution.
Oh, about orthogonality.
Yes, orthogonal.
Sorry, Shigi. I also don't understand about this topic well because I didn't focus on that lecture that time. So,
Oh guys, I guess I know the solution.
what is it?
What is that? Let's watch a video on YouTube.
Yeah, it's a great idea.
Hi guys, welcome back to my YouTube channel Professor Luke Explanation. So, in this video, I'm pretty sure you guys have difficulty in solving orthogonality problems, right? That's why you come to my YouTube channel, right? So, in this video, I'm gonna show you what is orthogonality and how we want to solve this problem step by step. Without further ado, let's get started. Hi guys. So, in your mind, what is orthogonality? First of all, I'm gonna tell you what is definition of orthogonality. So, orthogonality is a set of vector in bracket u1, u2, and others in Rn is an orthogonal set if each pair of vector from this set is orthogonal. That is, ui dot uj equal to 0 for all, but I is not equal to j. So, I know the definition quite difficult to bring. To make it simple, let me tell you that orthogonality is two vector in vector space if they are perpendicular. Means two vector is perpendicular to each other like this. So we have vector A and we have vector B. So the vector A and vector B is perpendicular to each other. So to get how it's to solve this problem, we use the dot product. And the dot product must equal to 0. So, if I am a student, I'm going to confuse how the product of this vector A and vector B equal to 0. So, I'm going to show you why the dot product between vector A and vector B is equal to 0. As we know, the equation of dot product is equal to length of vector A times length of vector B times cos theta. So the theta of this problem 90 degree, right? So we change the theta equal to 90, as we know that cos 90 equal to 0. So when 0 times anything, it's also equal to 0. That's why the dot product between vector A and vector B is equal to 0, because these two vectors is perpendicular to each other. So now we know what is orthogonal. To make it more clear, let I give you some example. So we have vector A and we have vector B, and by equation we want to see if this two vector is orthogonal. We have to use dot product. So this is the equation of dot product, and the dot product must equal to 0. So let's get started. We have to multiply 4 times 1 plus 2 times negative 3 plus 1 negative 2. So when we calculate, we get answer is equal to 0. Means vector A and vector B is orthogonal. So let's move to another part of orthogonal. It is orthogonal subspace. So now we have a subspace, and in subspace there is a vector. Now we want to make sure the subspace is orthogonal. By how? First of all, we have vector A and we have vector B. So if every vector in A is orthogonal to every vector in B, it means the subspace is orthogonal. So for any vector in subspace A and any vector B in subspace B, means A dot product B equal to 0. So the condition of orthogonal subspace is the vector A must start with A1, 0, 0, and vector B must start with 0, B2 and B3. So A1, B2 and B3 can be any number, because when we use the dot product between vector A and vector B, we also get the answer is 0. The property of orthogonal matrix. So the main benefit to having an orthogonal matrix is we can make inverse matrix so simple, because the orthogonal matrix, its inverse equal to its transpose. So if we have an orthogonal matrix, we know to find its inverse, we just have to transpose the matrix. So the next part is we can even consider orthogonality between functions. To do this, we must consider a definition for something we call inner product. So at the slide, we have fx and gx. We must define their inner product from the point A to point B. So if the inner product equal to 0, then the functions are orthogonal over the range A to B. Lastly, orthogonality plays a key role in several aspects of mathematics and even science, because it helps us break down systems into distinct elements for easier understanding and problem solving. So, are you clear about orthogonality? Because if you are clear now about orthogonality, I have some exercise if you want to do. So first of all, please pause the video.
A few moments later.
So as we know, if we want to solve orthogonal problem, we have to dot product between these two matrices. So 5 times 4 plus minus 1 times 7 plus 3 times negative. So what is the answer, guys? 7. Means the vector A and vector B is not orthogonal. Next, we move to the second question. we have use the same step, the product also. 3 times negative 2 plus 5 times 2 plus 2 times negative 1 and negative 2 also. So after we calculate, the answer that we got is 0. Means the vector A and vector B for the second question is in orthogonal. So I hope you enjoyed this video and I hope you understand better in orthogonality. See you in next video. Bye! Hi! Don't forget to like and subscribe. See you in the next video. Bye!
After watching the video, I guess I know and I understand what is the orthogonality is. Yes! Wow, great! So, let's do this equation together.
Alright, the vectors u 6 to 1 and vector v 0, -1, 2 are orthogonal. Let's do u dot product with v equals to 6 times 0 plus 2 times -1 plus 1 times 2 equals to 0. So these vectors are orthogonal.
Okay guys, hope you guys enjoy watching our video and I hope after this you have a better understanding in orthogonality to make your skill and improvise how to answer orthogonality. Make sure do some exercise at home. Thank you. Bye.